All right, so let's do number one. There's a lot of finding extrema, finding maximums, etc. So on this question, it says find the absolute extrema values of the function. So it could be minimum, could be a maximum. The answer choices on this one are all maximums, so kind of gives you an idea what the shape might be like. But let's go ahead and start. The process is always take the derivative, right? That should give me 5 times 4/3 times minus 1. That'll be 1/3, right? So set the derivative equal to 0 and find your extrema values, your critical values. So that'll be 20/3 x to the 1/3 equal to 0. It looks like it's going to be critical value or number at x equals 0. Although we have a bounded region, meaning these could be maximums or minimums. So we have to test. So test x equals negative 27, 0, and 8 to see what are absolute extrema. Okay. So when you have a bounded thing like this, you don't actually have to do the first derivative test. And let me verify on the exam real quick. Yeah, so sorry. So since these are all bounded, it's a little easier to figure out what's going on. And they didn't ask for increasing or decreasing. So you just got to plug them in and find out what's going on. So f of negative 27 is going to be 5 times negative 27 to the 4/3. What's that going to be? F of 0 will be 0. F of 8 will be 5 times 8 to the 4/3. All right. Grab my calculator. That's 16 times 5. Okay, I got 405 for this. Is that what you guys got? And 80 here. Okay.
Would that be negative 405?
No. Because you'd cube root it, which would be a -3, but then the fourth power would make it positive. And then times 5, still positive. But that's a good question. Which one's the biggest? It's an easy question, right? Where is my maximum?
Can you go up when you're done, please?
Do what?
Um,
Like this?
I got it. Thanks.
Okay. Max would be -27, comma 405, right? Minimum is at what? 0, right? Does this make sense? What we did?
Totally.
So if it's restricted, that's all you have to do. Test the endpoints, test your critical numbers, and decide what's the biggest and smallest. So this guy here was whatever, right? Didn't matter. And if we were to graph
And,
it, what's up?
The
I got
negative
negative 405.
It should be positive. Check your parentheses.
And the -27 is, it's one of the maximum numbers. I'm just curious why 0 isn't included before. Like,
So maximum meaning the highest point of the y value, right? So -27 gives you the highest output.
Ah, okay. Yeah.
Right, so this is the location of the peak, -27, 405.
Yeah. Okay.
So
that makes sense.
let's graph it so we can get a better idea here. So 5x to the 4/3. Right, here it is. So here's my minimum, right? Which we were correct. Let's zoom out a bit. Wait, do I have that right? 5x 4/3.
Is that it? Oh, no, positive.
I feel like I forgot something. Oh, shoot. I'm stupid. We have to restrict it, right? Because we have a x value at x equal to -27. Let's find out where that's at. I forgot that it wasn't a global maximum. All right, so here's the y value. So you go all the way to 408, right? And that's the peak. So it's not really a peak like usual because we bounded the graph. This is as low of an x value that you get. So we won't go beyond this point on the left side. So we go all the way to -27 and then all the way up until 8. So the other limit would be x equal to 8. So the graph is bounded between these lines here, -27 to 8. Does that make sense? So I'm only looking at from here, right? From here to here. Nothing else past that or before that this is considered. So this is my highest point. My lowest one is way down here. This one was disregarded because it's not as high as this guy, right? Even though it was considered to be critical. So boundary values, -27, 8, are always those could be extremas, absolute extremas.
I don't know how you get the 405.
Oh, you just plug it in the function, right? So just plug it into here.
Oh, okay. So you,
For the critical number, did you just like equal it to 0, or did you work it out like the 20/3? Like, how'd you get the critical number again?
Oh, the only way this would be 0 is if x is 0, right?
Okay.
Do you see or no?
No, I'm kind of blind right now. Let me see.
is it-
No, if you
So,
solve for x, like
Uh-huh.
okay, let's think about it, right? Divide both sides by 20/3. This just stays 0, right?
mhm.
And then get rid of the 1/3. Well, I got to cube both sides. Well, 0 cubed is still 0, so I'm gonna have x equal to 0 at the end of the day. But the only way this will become 0, another way to think about it, is if I plug in 0 here, 0 to the 1/3 times this gives me 0. So it has to be this.
Okay. So you're gonna always equal it to 0, right, to find the critical number?
Yeah, so you set the derivative, which is this, equal to 0, and solve for x. That's where this came from.
Okay, that makes more sense.
But yeah, make sure you put parentheses 5 times -27 to the 4/3. So you cube first, which gives you -3, and then -3 to the 4th would be 81. 81 times 5 would be
405.
yeah.
Okay.
All right.
Professor, what do you say you are? Mechanical engineer or electrical?
Undergrad I did electrical, masters I did mechanical.
Awesome. All right.
Let's see here.
By the way, I don't know if you did I? No, I got selected for the internship for Tamuk.
Oh, nice.
Yeah, what's it? Bionic hand.
Oh, that's really cool, man.
Yeah.
Congrats.
Thanks.
Well, that reminds me, I gotta send you guys an internship for NASA. I'll do that tonight before I forget.
What kind of requirements are there?
It's all in the email. I'm gonna forward it to everyone in all my engineering and calculus courses. Hopefully, you guys meet those requirements. I need to read it again though. I got it, I think, yesterday. I have not looked too deeply yet, other than I need to share it with you. Let me see. I'm curious now. Yeah, I'll have to look later. I don't know where I put it. You guys have any questions on number 1?
Nope. Next.
All right. Number 2 is the same deal. It's just a sine function instead of a power function. So let's do number 3. This one is not bounded, meaning you can only check the critical points for possible maximums or minimums. So let's go ahead and use the first derivative test, because doing 2 derivatives of this guy would be annoying. Determine. But all they asked for number 3, actually, now that I read it, Determine all critical. Points for the function. F of x is equal to x plus 2. There we go. I don't know why I wrote that so ugly, but whatever. So we have to do quotient rule, right? I forget what the minus goes. Every single time. Okay, g f prime minus f g prime. Yeah. All right, so take the derivative. No choice. So it's going to be the bottom times the top derivative, first derivative, minus the top times the derivative of the bottom. Everything squared. Okay, so this derivative is no big deal, right? This will be just a 1, so it won't matter. Negative negative would be a plus 6x over this guy squared. This will be negative 6x minus 12 plus 6x over x plus 2 squared. So these are gone. So f prime of x is equal to negative 12 over x plus 2 squared. Does this have any critical values? Right, remember we have to set f prime to 0 to find the critical numbers. So that would give us negative 12 over x plus 2 squared equal to 0. Will this ever be 0?
No, because it'll be undefined.
Yeah, that's like the best thing we could do is find the undefined value, but since the undefined value is also undefined here, we can't use that as a critical number either. So this has no critical numbers. And the question asked to find that, right? Let's see. Yeah. So the answer would be B. There is no critical point. Oh, well. You guys see why?
Critical points are not the same as points of inflection, correct?
A critical number or point could also be an inflection point.
Got it.
Okay. Any questions on number 3?
There are vertical asymptotes though, right?
Yes, there is.
Okay.
Did you say that there wasn't any points of inflection?
No.
Okay. Because there was no critical number?
Right.
Okay.
All right.
Next.
Number 4 tells you to find the extreme values, but then determine if it's a minimum or maximum, or if maybe you have both. Who knows, right? Number 4. Find the extreme values of the function and where they occur. So y is equal to 9x over x squared plus 1. Sadly, this is another excuse me, quotient rule. Okay, so I keep writing it.
Professor, doesn't matter if the function is y equals or f of x equals and then the function?
No, it doesn't matter. The notation, when you see y equals, technically what it's supposed to be is y of x.
I see. Yeah.
But some people get there's some math people that don't like it. Excuse me.
Can even be h of g or g of x or whatever, right?
Right. So y is just the name of the function. Y of x represents an input, but it could be f, g, z, whatever.
Got it.
All right, so first derivative. Be the derivative, or the bottom times derivative of the top, minus derivative of the bottom times the top. There we go. So we're going to get 9 times x squared plus 1 minus 2x times 9x. Okay. That will give us 9x squared plus 9 minus 18x squared, right? So that'll give us a negative 9x squared plus 9 over x squared plus 1 squared. You guys agree?
Yep. What formula do we use here? The quotient rule?
Yeah, that was quotient rule. All right, so set it equal to 0. See what's going on. So set y prime equals to 0, and find your critical numbers. All right, here we go. So negative 9x squared plus 9 over x squared plus 1 squared equal to 0. The bottom is not going to have any, not really going to do anything for us because it will never be 0. Only the top can make the whole thing 0. So we are really solving this guy here, just so we don't have to write as much. So set is equal to 0. Or sorry, isolate the x squared I meant. Divide the 9 out. Square root both sides, and x becomes plus or minus 1. And skip some algebra there. Do you see how we solve for x?
Shouldn't the 9 be a negative 9? That would cause it to be imaginary numbers.
If you moved this 9 over here and then divide by negative, because they would both be negative, right?
Oh yeah, true. Yeah, you gotta get rid of the 9. But wouldn't that just be? Oh yeah, because they're both negative. That would just turn into a 1. You're right. Sorry.
No, it's okay.
I messed up on my end.
I skipped a few steps there.
Very cool.
All right, so we have 2 critical numbers, right? X equals 1 and negative 1 are the critical numbers. And since this required a quotient rule, I do not want to do a second derivative. So let's use the first derivative test to find out what's going on here. Let's see here. So here's a 0. Well, here's a 1. Here's a negative 1.
You scoot your paper up just a little bit.
Yeah, thanks. So I was going to pick some numbers that are easy to deal with. So I'm going to put little dots on the ones that are critical. All right, let me make a table, make it a little easier this time. Here's the.
Here we're gonna take the derivative and then plug in the numbers. Not a critical, but
Yeah. Sorry, go on.
The number line, right? So we'll just put -2 instead of x.
Yeah, just plug it into the derivative so you can see if it's positive or negative. So here are the x values. I chose -2, 0, and 2.
Wouldn't this tell us if it was increasing and decreasing? Is that what we want?
Right, that's what we want to know. So if you plug in -2 into the derivative, that's this guy here, right? The bottom will stay positive no matter what because there's a square here. Plus this is squared, so it's squared and then squared again. So the bottom will have no hold on the inputs, at least for the sign. The top though, if I plug in a -2 here, that'll give me 4, positive 4. Positive 4 times negative is a negative 36 plus 9. It's going to stay negative. So this will be, well, I don't want to be weird. I should probably
Negative?
show the work. Yeah, it's going to be negative, but I'm trying to decide if I should skip that or not. I think I should not. All right, so -2 would be equal to -9 times -2 squared plus 9 over -2 squared plus 1 squared. So what's that going to give us when you plug in -2? All right, so it's going to be minus right here, right? If you plug in 0, this will become a positive, so this will be plus. So this will be minus, plus, oh man, pen's being stupid again. And then this guy would be the same output as this because we're squaring it, so it'll be negative. Anyway, you guys cool if I skip this part, or is that, you want me to write this on a different page?
Yeah, no, that's fine with the first
Okay.
step.
Okay. Because yeah, I was like, I don't think I can fit this in there. It's gonna look shitty. But anyway, so we're decreasing, right? Decreasing from here, and then increasing. And then after that, I'm decreasing again. So this is my shapes, right? So we have a minimum at -1, maximum at 1. Is that clear?
Yes.
Okay,
Yeah,
so let's look at the answer, yeah? So here it is. So -1, we said it was the minimum, right? At -1. Maximum at x equal to 1. These values here, I didn't find them, but you would plug 1 into here to get -9 halves and 9 halves. Just plug in the x values. But once you know what they are, you can technically choose the answer already, right? But we should show our work either way. Is it clear on how you get this right here?
Yes.
Is there any questions on any of the steps here?
So because it's increasing from -1 to 1, the highest point would be at the 1, right?
Yeah, because it's going up, and then it gets there, and starts to decrease. So it no longer increases, so it has to be the biggest point.
Okay. Makes sense. Thanks.
Well,
We need to
that's
show you the graph over here and this table also.
Yeah, I would say just this would be your first derivative test here. So what I want to see on the test is the first derivative, right? So this guy. And then I want to see the critical numbers. That's this. And then test around them. So this would be enough to show that you know which ones are minimums and maximums.
Okay.
This is the first derivative. Stupid pin. I think it's this page, maybe. Let me find another pen. Okay, let's pick another one. You guys are cool on that one, right? Number 4. Okay.
Yeah.
Yes, sir.
So number 5 is what the mean value theorem, and that's not going to be on the test. So I'm going to skip that guy there. Number 6. Okay, number 6 is asking for increasing and decreasing. So the procedure will be similar to what we just did. So you gotta give the intervals. All right. Use the derivative of f of x given below. Determine the intervals on which f of x is increasing or decreasing. All right. So this one, they were nice enough to give us the derivative, which is this: x to the 1/3 times x minus 6. So we need to figure out what the heck's going on. So find the critical points first.
Is that a x to the power 1/3 or
Yeah, 1/3.
I thought it was 4? Okay.
Find the critical numbers by setting f prime to 0, right? Okay. We already got it factored and everything, so it's going to be easy to see what makes it 0, right? If you have something that's factored, and in other words, multiply together, you could simply just set each part to 0 and solve. So x is 0, x is 6. That makes sense?
Yep.
Okay, so we got the critical numbers. So now let's do the first derivative test. Yeah, let's do that. That'd be easy. All right, so we got 0 and we got 6. So choose easy numbers between before and after. So here's 1, here's 7. These are my special numbers. And -1, I guess. Okay. So let's show our work this time. So what we're going to do, hopefully this pen allows me to, plug in x equals -1, 1, and 7 into the first derivative. All right. I have to start buying my own pens because the ones they give me are trash. f prime of -1 is equal to -1 to the 1/3 times -1 minus 6. I can't even see that. Can you guys see that?
No,
Plus positive.
See if one of these 20 pins will work.
I will send you a pack, sir.
Thanks, man.
una pichera.
Yeah, the ones I bought were really nice. They worked for about 2 weeks and I ran out. That went back to the ones they gave me. And here we are. Should stick with my own pins. Right. I think this is better, right? Okay. So is that going to be positive or negative?
Positive.
Yeah, because this is negative, right? That's negative. So negative times negative.
It's positive.
Yeah. Okay. All right, let's try it again. F prime. God damn it. But I started writing in rainbow colors. F of 1. Is this positive or negative?
Negative.
Yeah. F of 7. It's positive, right?
Yes.
Is
So we
it-
get-
Sorry, is it ever safe to assume that it'll go from positive, negative to positive in like some form of pattern or?
The only thing you can assume is that after a critical point, if you find the number after to be positive, then it will stay increasing from that point on. So from here to infinity, I can say that. But you could get repeated. You could get all of them to be decreasing or all of them to be increasing. So sometimes that
Okay.
happens. All right. So f of 1 was a negative, right? F of -1 positive. So we got this going on, then this going on, then this going on.
Now, can we? I don't think we have written the where it's increasing or decreasing in interval notation, because I remember they were asking interval notations.
Yeah, interval would just be using the parentheses, right? So
Correct.
increasing is going to be negative infinity all the way till -1, right? And then we have the other part.
Negative infinity to 0.
Yeah, that's a critical
Yes.
number. Yes, yes.
Correct. Zero.
Thanks.
Yeah, no problem. I was just making sure it was good.
All right, and then you union the other increasing part, which is 6 to infinity, right? Okay. Decreasing. All right. Seems like they only last for like 2 minutes at a time. All right, let's try this again. Decreasing was only in the middle, right? 0 to 6. Okay. All right. Anyway, sorry about this pen issue, but do you see the main idea? Right? How the first derivative test works?
Yeah, very useful.
Okay. Let's go look at a different one. Number 7 and 8 are the same type of deal. Number 9 moves on to a different topic. It's L'Hopital's rule. And number 10 is the one that's going to be a little annoying. So let's do that guy too. Although we've been going at it for a while, let's take a small break. It's 9:58. Let's come back at let's see here. I guess 10.
Yeah, that sounds great.
All right. We'll end up with an indeterminate form, right? Which means we have to do L'Hopital because, well, we're allowed to use L'Hopital when we have this situation. Okay. So L'Hopital's rule would be you take the derivative of the top and bottom, and then you see if you're able to take the limit at that point. The derivative of the top, derivative of the bottom. The limit would be 0, right? Because the bottom is growing faster. It's going to infinity. We can kind of already see that here, but they want us to do L'Hopital. There it is. Any questions on number 9?
So the answer is 0.
Yep.
And the only work we have to show here is what?
Just taking the derivative of the top and bottom, and then taking the limit.
Oh, the
okay.
derivative. Okay, take a derivative, and then what?
And then you take the limit. Because at first you couldn't do it because you have infinity over infinity, which this tells you to do L'Hopital. Once you do it, you see, okay, now am I able to take the limit? If you can, then you stop. Okay.
So for the Lubital, we just put infinity over infinity, or
This tells you that you can do L'Hopital. When you see an indeterminate form. Okay. Number 10 wants a lot of stuff. Okay. All right. I'm gonna write the question over here. This is just too much to write. So they give us this equation. 2x cubed minus 3x squared minus 12x. Okay. Excuse me. So it wants the intercepts, asymptotes, local extrema, concavity. This does not have asymptotes because it's not a rational function, so we don't have to worry about that. Intercepts, well, we'll probably have to factor and see what's going on. Concavity and inflection requires derivatives, so let's go ahead and find those first. So first derivative will be 6x squared minus 6x minus 12. Second derivative will be 12x minus 6. Okay. Set this to 0, so find the critical points. All right. This is all divisible by 6, so factor that out. Divide it all out, that will give us this guy here. That will factor into x minus 2, x plus 1. So x equals 2, x equals negative 1, right? Those are the critical numbers. All right. Inflection points, you've set the second derivative equal to 0.
Could you scroll your paper down just a little bit? Thank you.
So this would be 12x equal to 6, x equals 2. So it looks like this guy is an inflection. Okay. Negative 1 is probably the extrema. Alrighty.
And how would that question be phrased?
Oh, I threw it in the chat, the question.
Okay, thank you.
What was I doing? Okay. So plug this guy into the second derivative to find out if it's a concave up or down, meaning it's a minimum or maximum, right? So plug in
-18.
into y double prime. You got, well, how much? What'd you get?
-18.
Okay. 12 times -1, yeah, looks right to me. Meaning concave down, right? So this guy is actually, or sorry, this one is a maximum. Okay. So we found.
Can you go over what you did to get the 2? Like I don't think I'm missing the manipulation.
Let's see here. Yeah, maybe I made a mistake. Because it's 12x, right? Divided by 12, that should be a half, not a 2. My bad. There we go. So this is not an inflection point. It could still be a minimum. All right, good thing you mentioned that. All right. So plug in, let's go ahead and plug in 2 then into the second derivative. That would be 12 times 2 minus 6, right? Which is positive. What would that be, 18? Just 2 times 24, right?
Yes.
Concave up. So this is a minimum. All right. So we got a bunch of information here. We got the critical points. So now we know we have a minimum and maximum. We know there's no asymptotes. We should probably find the intercepts now. And that's stuff from college algebra or before, right? Find intercepts. Let x equals 0 to find y-intercept.
Is that a different question?
Nope. Let y equals 0 to find, just writing some notes for finding intercepts because we haven't found them yet. The equation that they gave us is 2x cubed minus 3x squared minus 12x. So let y be 0, x be 0, we get 0, right? So it looks like we got a intercept at 0, 0. So this is for finding the x, or sorry, the y-intercept. It just turned out to be an origin point. Now let it equal to 0 and find out if there's any other solutions here. So they all have an x, so factor that out. Be 2x squared minus 3x minus 12. Does this factor nicely? I think it might. Nah, maybe not. Is a 6 going to 24? 4 times, right? That won't work either. Nope.
What number is that? Negative 24?
Yeah. I'm checking on the multiples of 24.
Yeah.
I don't see I think I got them all right. Got 4, 3, 2, 8, 6. Yeah, I don't think it factors.
Yeah, nothing adds up to -3.
Nope. So the only solution here is x equal to 0. So it looks like this is our only intercept. So put all this information together and you should be able to sketch a graph. So I know I got a point here, right? We have a maximum at -1. We have a minimum at 2. Okay, so plug these into the original. What do you get? Right, plug in -1 here. What would you get? I think it's 7, right? Yeah. So 1, 2, 3, 4, 5, 6, 7. So we got a point here, which we said it was a maximum, right? Something like this going on. Oops. No. Sorry. -1 was equal to 7. So we got a maximum over here. So we know it goes down like this. It goes through here. Then comes up at some point. And 2 is supposed to be a minimum. Yeah. So this is the idea behind sketching. It's not very pretty. But somewhere way down here, this starts to go back up. And goes like this. So something like that. There's my shitty sketch there. Using the idea of a maximum and a minimum and an intercept, I can get an idea what the picture looks like. This guy probably keeps going downward for a while. Oh, man. Anyway. But since we have graphing tools, we can verify this, right? We don't have to do it old school. It's just that they told us to. 2x cubed. Let's go ahead and graph this guy. See how much prettier it is on here. Yeah, kind of got it right, a little bit. So do you see the idea here? You use the idea of a minimum, maximum, and intercepts to help you get an idea of what's happening with the graph. You would have to plug in the x value into the original to get this guy, 7. You got to plug in 2 into the original to get to -20. So you would plot the location of the maximum, location of the minimum, location of the intercepts. Usually you might have 1 or 2, but whatever. It looks like there are 2 x intercepts, which would come from solving this guy here. If you do the quadratic formula on this thing, which would not be fun, you're going to get 1.812 and 3.312. So it would be more exact. So you see how I kind of just guessed where it came down and where it came up, right? This would be determined by those intercepts. So it'd be more over here. This would be more over there. But anyway, so when you get to a question like that, what I want to see is, you find the intercepts. Can you tell me the maximums and minimums? Can you tell me the inflection points? And if you can, then you should be able to give me a rough sketch. The sketch doesn't have to be good. Clearly, this is not good. But I do expect you to be able to get me all that information. Okay.
And what were you doing with negative 24 again?
Oh, I was trying to factor this without the quadratic formula, but it could not be easily
Oh,
factored.
okay.
I never liked the quadratic formula.
Yeah, it's like the last resort, man.
And that would have gave us the intercepts, right?
Yes, so it would give us these guys right here. The 3 point. See how this is a lot more narrow than my guess, because
Yeah.
they knew where they went through. I only knew an idea, or I only had a vague idea that it was going down from here and going up from there.
Okay. Thank you.
Okay. So the answer is C.
It is C or E?
I'm sorry, what did you say?
It is C or E, because the graph looks more like a C. I mean D.
The third one.
1, 2, 3. Okay.
Yeah, unless it's randomized, I don't. On mine, it's C.
Okay. So here's D.
Oh, okay. I don't know that. All right, so for problems 13, 14, and 15,
Minus
those are from the differential section that I threw out. So don't worry about those. If you see them on the test, just either skip them. If you decide to do them, I'll give you extra credit, but they're not for a grade. Okay.
Which numbers were they again?
The last three on the review. On the actual exam, it's gonna be. Let me see. Give me a sec. Yeah, the last two on the actual exam would be extra credit. So just skip them if you want to. Okay. Let me see if we have time for one more or not.
How many questions on the exam?
10.
Thanks.
Okay. Let me see if we can do 11, or at least try to. So word problem. Here's the picture. So rectangular sheet of perimeter 27. Dimensions are x by y centimeters, is to be rolled into a cylinder. That makes like a can, I guess. What values of x and y give the largest volume? Okay. Now let's write down the perimeter. Perimeter is equal to 2x plus 2y, right? P is equal to 27. What is the volume of a cylinder? And if you ever forget, just a good easy trick is to think of it this way. What's the area of a circle?
3.
What's the formula? That's one we know, right?
Pi r squared.
Pi r squared.
Yeah, pi r squared would give us the circle. And you agree that this is just a stack of circles, right? So you do pi r squared times the height, that gives you the volume of a cylinder. So volume is equal to pi r squared times h, but we're not using h or r, right? So circumference is equal to x. What is the formula for circumference?
2 pi r.
Yeah, circumference is equal to 2 pi r, which is equal to x, right? Okay. This one will be easy to switch out. Let me switch back over here. Right. You see how this is just going to be y, correct? The radius, though, should that be x squared or should that be something else? They told us in the question that circumference is equal to x. Which makes sense because that's the width or length of the sheet. Okay. So if I solve for r, do you agree that r is equal to x over 2 pi? Is that weird?
Yes.
So wouldn't the volume formula just be pi times x over 2 pi squared times y?
Just
That'll work.
3 pi.
You see what I mean?
Mhm.
Okay, so in the formula's trying to look. So the goal here is to get the formula in terms of one variable, right? If possible. So we're going to use the perimeter to help us out. So perimeter is equal to 27. So 27 is equal to 2x plus 2y. Solve for y, that'll be 27 minus 2x equal to 2y. So 27 minus 2x divided by 2 is equal to y. So now I got the volume formula in terms of x only. So it'll be pi times x over 2 pi squared times 27 minus 2x over 2. There you go. So now we have v as a function of x, which is perfect. Although it looks disturbing, but but the math is legit. Is there any questions about how we got here? Let's try to do some algebra because it looks like garbage.
Yeah, I get it now.
Okay. I'm gonna just cancel one of those pi's out, right? 4 times 2 will be an 8. So I can bring the 8 together. 4 times 2. The pi is still there though. X squared times these two, we got to distribute. So that'll be 27x squared minus 2x squared. All right, that looks prettier, right?
Yeah, it does.
Cubed. All right. So back to the question, because this is just setting it up, right? It wants us to find the x that maximizes the volume. In other words, find the critical number of this equation, right? Because this is all equal to v. So find dv dx. That would be, what's 27 times 2? What's that, 54? Okay. You agree with the derivative?
Mm-hmm.
Set that equal to 0 to find the critical numbers. So 54 x minus 6x squared over 8 pi equal to 0. 8 pi won't matter because I can cancel it by multiplying both sides by 8 pi. So now I just need to solve for this. So they both have, does 6 go into 54?
Yes.
It's 9.
9? All right, thanks, man. So there are the critical values. So this implies that 6x equals 0. 9 minus x equals 0. So x is 9, right? X is 0. So there is my
Critical points.
2 critical points, but this one represents what? Right, this maximizes the volume.
Okay.
We can't choose 0, right? Because remember, what are we solving for? Let's get back to the picture.
The largest number value of x or y.
Yeah, we want to figure out which x and y will give me the biggest volume inside my can. So it's like you're trying to cut a piece of sheet metal, roll it up into a can or container or whatever. So by putting everything in terms of x, taking derivative of the volume equation, then we got 9, right? So plug in 9 into the perimeter equation, or perimeter, and you can solve for y. So this is the perfect dimensions to give you the most volume in here. Okay. Okay, so remember that y is equal to 27 minus 2x over 2. So plug in the 9. So that would be 27. What's 2 times 9? Is that
18.
27 minus 18? That'll be what we wanted, right? Okay. So these dimensions. So x equals 9 and y equal 9 halves maximizes pin's dying again. The volume. Is there any questions on what we did here? Does the logic make sense?
Yes.
I know the math is a little difficult, but the idea is there, right? Right. We use the circumference to help us solve for r. We use the perimeter to help us solve for y. And then we simplify the volume equation into nothing but x's. Is what we did here. Did some algebra. Got to here. Took a derivative. Got this guy. Set it to 0 and found the critical numbers. Do you have any questions?
When is the test?
I forgot.
Monday, right? Or Wednesday?
So, how many questions is it?
10.
Could we have till Thursday so it's not due on the day of a class?
Yeah, that's fine, man. Let's see here. Yeah, or currently it says what's today? Yeah, you're right. It's actually the 26th, so I have a lot of time still.
So, on Monday, we're gonna be covering new topics.
Monday, I mean, if you guys want to ask a couple of questions, I don't mind. But after that, I'll probably move on to the beginning of chapter 5. And Wednesday, for sure, I'll cover probably 2 or 3 sections.
Okay.
So you have to the 26th, but I advise you that you get out of the way sooner because chapter 5 will start piling up, and then you'll have another test before the semester ends.
Can you skip the last test?
And again, sorry, it was kind of hard to hear you. You said 9 questions?
10, but 2 of them are extra credit, so
10. Wow. Okay.
you know some of those can take time, like the sketch problem or the that something like this that we just did.
Yeah.
Yeah.
I take a lot of time with the test, so when the review has like twice the amount, I struggle. But yeah.
Yeah, I mean, review is not for a grade, so don't worry.
Yeah.
But just know that the this is the optimization problem. You'll have one of those. It's not going to be the same, right? It might be a sphere or something else. I don't know. But the idea is the same. The approach is the same. It's just different formulas that you'll have to come up with. I recommend writing down like a bunch of area and volume formulas if you don't have them memorized in your head. I'm not going to judge you. Just to be safe. All right, guys, have any more questions?
No, I just gotta talk to you after class.
Okay. I guess, well, that's it for today. So we'll review a little bit more next time, and then we'll figure it out from there.
Okay.
Have a nice night.
Too.
Have a good night.
Thank you. Bye.
Bye.
Yeah.
Hold on 1 second.
Yes.
Okay. All right. What's
Okay.
up? What's up, Rodolfo?
No, I just I saw the email you sent today about the help we need if we need help.
Mhm.
Yeah, I got a little bit behind on this class because I got the engineering class, and this teacher is giving us a lot of homework. So, and besides the problems I had the last week or when I asked you to extend my exam. So yeah, I got behind on my homework basically on the